Hello viewers, I am Dr. G. Littleflower, faculty from Department of Physics, Stella College. Happy to welcome you all for a talk on optical fibers and their types. I already have spoken in the earlier video about the optical fibers, their designing, the materials used and their applications. In this video, let me explain to you about their types. There are many types. So let us see that here. Before taking up, let us see what are called optical fibers. Optical fibers are very thin, flexible strands made primarily of glass or plastic, which will transmit light signals over long distances with minimal signal losses. Fiber cable construction. There are many different ways an optical fiber can be constructed. Let me discuss a few ways here. So this is the optical fiber. We know the optical fiber will have a core surrounded by a cladding, and there will be a coating and one more layer strengthening fibers, and it will have a cable jacket. The core generally made up of pure glass or plastic, which will be helpful to transmit the signal from one end to the other end. The refractive index of the core should be higher than the refractive index of the cladding. That is the main condition. Core refractive index should be higher than the refractive index of the cladding, so that the signal could be confined within this core. The optical fiber cable may be thicker, but the core is very less diameter, through which only signal will be conveyed from one end to the other. So cladding, it is the surrounding layer of the core, and its refractive index will be lesser than the refractive index of the core, so that the signal will be completely confined within the core. And these two will be surrounded by a coating called or buffer. It's an additional layer made of plastic, and it surrounds the cladding, which protects the fiber from physical damage, moisture entry into the core, and other environmental factors. The next one is called strengthening layer. This layer is also known as Kevlar. It's made of the material called yarn type material. It surrounds the buffer jacket. It increases the tensile strength of the cable. Means during the summer, more heat would be there. The optical fiber cable length should not be affected, or during winter time, the length should not be contracted. For that sake, they keep a strengthening cable so that the tensile strength can be increased. Then all this one, core, cladding, coating and the strengthening fibers will be kept inside a jacket. This jacket is the outer protective tube, which is filled with polyurethane, which prevents moisture from entering into the core. Now, types of optical fibers. First, we can differentiate the optical fibers based on material. The core could be made of glass with glass cladding, glass core with plastic cladding, plastic core with plastic cladding. So, three types: glass with the glass with the plastic, and plastic with plastic. Based on the mode of transmission, the optical fiber could be single mode fiber or multi-mode fiber. And based on index profile, step index fiber or graded index fiber, based on the refractive index, these two types are made. Now let me explain how optical fibers can be categorized based on material. So the optical fiber core and cladding can be made of glass material only. So this type of optical fiber will have lower signal loss compared to glass core with plastic cladding. And the glass fiber is suitable for long distances and high speed data transmission, such as telecommunications. But the drawback of glass core with glass cladding is that such type of optical fiber is not immune to the radiation effects. Radiation could affect the signals. So when we compare the glass core with the glass cladding with the glass core and plastic cladding, the glass core with plastic cladding will be superior in preventing the radiation reaching the core. So in such case, if you want to use glass core with glass cladding optical fibers and protect it from radiation effects, you need to design specially radiation hardened glass. So that is possible by the addition of some impurity atoms while designing the glass core and glass cladding part. So that way the cable will be protected from radiation. The next is glass core with the plastic cladding. It introduces higher signal loss. Whenever plastic, when we use the refraction of the signal, scattering of the signal or attenuation will be more. So plastic cladding often introduces higher signal loss because of its lower optical quality and mismatch with the glass core. So which leads to more scattering and absorption of the light signal. Though it is low in cost and less affected by radiation, it could be used only for military applications. The next category is plastic core with plastic cladding. So totally it is made out of plastic, so definitely it will be lighter in weight. This type of fiber cable have same material, so it is easy to produce also and easy to couple also. Whereas in the earlier case, glass core and plastic cladding, coupling them will be very difficult. Whereas here, both are made of same material, so it easy in production and less expensive and easy to install. Mostly used in short distance communications only. Now we come to optical fibers based on mode of transmission. There are two types, single mode fiber and multi-mode fiber. Single mode fiber is shown here. So using the LED source or the laser diode, only single ray of light at a time will be allowed to enter into the optical fiber. With the help of total internal transmission, it travels across the tube and reaches the destination. So only one path, and the diameter of the core will be very small, 8 to 10 micrometer only, and it is very low cost and attenuation loss will be very less. Also dispersion will be very less, so that the data can be transferred with a high speed across the cable. The bandwidth up to 40 gigahertz can be transmitted from one end to the other end using this single mode fiber. So this type of single mode fiber will be used for long distance communications, especially telecommunication and internet. Yes, multi-mode fiber. So here you can see the laser diode or the LED source will send multiple rays across the cable. Multiple rays simultaneously at the same time. Many signals will be passing across the cable. Light and the core of the multimode fiber will be higher than the diameter of the core of the single mode fiber. Core is having 50 to 62.5 micrometer. The designing cost is very less cost effective, flexible and easier to install for short distances like local area networks. Within the campus, if you want to connect all the computer systems, local area networks will be used. So in that, this type of multi-mode optical fiber will be used. With more signals, there will be lot of dispersion. That is the drawback of multi-mode optical fiber. So here also I have shown an optical fiber. You can see the core here surrounded by the cladding. Suppose if we represent the refractive index of the core as N1, refractive index of the cladding, the outer layer will be having N2, and the refractive index of air is N0. So N0 value will be, for air refractive index will be 1, the core should have more refractive index, so it is 1.47. The cladding should have a refractive index around 1.45, which is lesser than the refractive index of the core. So here 3 different rays are there. It's a multi-mode optical fiber. The diode, laser diode or the LED is sending 3 rays. For example, we have chosen. So one ray is just taking up the path of straight path from one end to the other end, and the other ray, it is incident at an angle. So this ray strikes the boundary between the core and the cladding at an angle, critical angle, so that it undergoes multiple total internal reflection and reaches the other side. If you take up this ray, it strikes a boundary between core and cladding at an angle lesser than the critical angle. So what happens? It undergoes refraction. The signal escapes. We want all the 3 signals to reach the other end, but the angle of incidence at the boundary is different. It is lesser than the critical angle, so it just gets away from the core, and that way leading to signal loss. The third mode exceeds the critical angle and refracts into the cladding. So it can be seen that the second mode travels a longer distance than the first mode. Longer distance than the first mode, causing 2 modes to arrive at separate timings. This is what we refer as dispersion. You can see the 2 rays. One is traveling straight path, so lesser time, whereas the ray which is striking the core and cladding at an angle, critical angle, undergo total internal reflection, and the ray which is striking the boundary at an angle greater than the critical angle undergoes refraction. So these two, so this is not reaching the other end. The other 2 rays, if you see, they are reaching the other end at different timings. The straight path will be a shorter path, so more fast it can reach. The other one is taking little extra time. So there is difference in time reaching the other end. So this is what called dispersion. Okay, this disparity between between the arrival of times of the different light rays is known as dispersion, which is unavoidable characteristics of multimode step index fiber. So while designing, we have to take this point into care so that we can minimize the dispersion. So once again, a simple picture with the LED source or the laser source. We have, this is a single mode fiber. Only single ray at a time will be passing through the cable. This is the multi-mode fiber. So the LED source or the laser diode will send multiple rays simultaneously at the same time. So the core of the multi-mode fiber will be greater than the core of the single mode fiber. Okay, the other dimensions are there, you can go through. Once again the same thing. So here this picture, this is what called single mode fiber and multi-mode fiber. This is a third category based on the index, refractive index, how it is marked, that will be explained now shortly. So this is single mode fiber, multi-mode fiber. The core diameter is more than the core diameter of the single mode fiber. The last one is in terms of refractive index, how it is differentiated, we will see now. So index profile, step index fiber. So here also we have 2 types. So step index fiber, multi-mode graded index fiber. So 2 types are called. There are 2 types, step index fiber and graded index fiber. In the step index fiber, this is the step index fiber, you can see this core. Core will be having the same refractive index. So this is a small graph between the refractive index and the radius of the cable we have taken. So if you take the core, so it's a cylindrical cable, the cross section will be circular in nature. So if you take the core, will be having same refractive index, and the refractive index will be higher than the refractive index of the cladding. Okay, so refractive index is a step higher than the refractive index of the cladding. That is why it is called step index fiber. Next one is graded index fiber. Here you can see the refractive index of the core will be decreasing from the center towards the cladding. Okay, decreasing, or we can say cladding refractive indexes. This means the refractive index of the core will be gradually increasing from the cladding to the center of the core. So it is named as graded index fiber. With the graded index fiber, dispersion will be less. Okay, dispersion will be less. In the previous slide we said that multi-mode fiber means many signals can be passed through the cable, but there will be dispersion. So if we design properly so that if the multi-mode cable becomes graded index profile, if it is based on that, then the refractive index of the core will be varying from the center to the cladding. So it decreases from the center to the cladding. By this way, if you do the design the core having different refractive index over the distance from the center to the cladding, that type of designing will eliminate the dispersion and make it suitable for many applications. So here once again a simple picture, multi-mode graded index fiber. You can see from the core to the cladding, the refractive index is varying, so you can call it as a graded index fiber. Then we send many signals at the same time, so you can see one is traveling this way, and the ray which is striking the boundary between the core and the cladding, if the angle is at the critical angle, happily it is undergoing multiple total internal reflection and coming out. Another ray also striking at the critical angle undergoes multiple internal reflection. The only one care what we should do is if the refractive index of the core is Na and the refractive index of the end of the core is Nb, so Nb should be lesser than Na. That means graded. The core of the fiber is having refractive index varying from center to the end. That way it is graded. So dispersion could be minimized. Now another figure I have shown here comparing all that. This is single mode step index fiber. The core diameter will be very less and only single signal can pass through. Then this is multi-mode step index. This is multi-mode gradient index. So you need to know the difference between multi-mode step index and multi-mode gradient index. In multi-mode step index, the core will be having same refractive index. In multi-mode gradient index, the refractive index of the core will be varying from the center to the end of the core. Okay, so it is gradient. You can see the signal given here will be just traveling like this, whereas multi-mode gradient index based on the refractive index of the core, some rays will choose a straight path, some will be the angle of incidence is upward, means it will be taking a path like this. So they will be safely traveling to the other end. Now let us make a comparison between single mode fiber and multi-mode fiber. In multi-mode fiber, light can propagate in number of modes, means as a cluster of signals differently. They can travel different points, they can choose within the optical fiber and can travel simultaneously. Whereas single mode fiber, light can propagate in a single mode only one. And then here multiple signals are given, so multiple excitation, different modes would be there. So the rays which are entering into the cable at different angles will excite different modes. Whereas in the single mode fiber, only one signal we are setting, so only one mode of excitation is possible. Multi-mode fiber is best designed for short distance communications, whereas single mode fiber is best designed for longer distance communications. And then that multi-mode fiber has low capacity to transmit information over shorter distances, whereas single mode fiber will have higher capacity of transmission, and it exhibits more dispersion. Already we kept on telling that multimode fibers will have lot of dispersion. That way signal loss would be there, whereas in single mode fiber dispersion won't be there. So it is suitable for longer distance transmission. And then attenuation also will be more in multimode fiber, whereas attenuation will be less in single mode fiber, and that way multimode fiber can transfer less information per unit volume, whereas more information can be transmitted in single mode fiber. And multimode fiber is suitable for LAN, local area network connections only, whereas single mode fibers are suitable for long distance communications. Losses. There are losses when we send the signals in the cable. Losses in optical fiber result from attenuation in the material itself and from scattering. Scattering would be there, attenuation would be there, which causes some light to strike the cladding at an angle less than the critical angle, so it undergoes scattering. Now we wind up the optical fiber. It can be, so when you bend the optical fiber also too sharply, then that also will lead to some losses, causing some of the light to meet the cladding at less than the critical angle and getting scattered away. And then losses vary greatly depending upon the type of fiber. We know by the time now you will be able to tell multimode fibers will have lot of losses, and this losses depend upon the type of fiber. Suppose if you have a plastic fiber, have losses of several hundred decibels per kilometer. Over a distance, the signal loss will be over several hundred decibels. If you use a graded index multimode glass fiber, the loss will be around 2 to 4 decibel per kilometer. So this comparison, right? Both may be plastic, but if the core is having the refractive index of the core is graded, then the loss will be 2 to 4 decibels only. If it is a single step, the core refractive index is same, such type of fiber will have several hundred decibels loss per kilometer, whereas single mode fiber has a loss of about 0.4 decibels per kilometer only, or even lesser than this. That is why single mode fibers are finding much applications in long distance communications. Designing difficulties. Multimode propagation will cause dispersion, which results in the spreading of pulses and limits the usable bandwidth. Single mode fiber has much less dispersion but expensive to produce. It is very small and its numerical aperture will be very smaller than the multimode fiber, makes it very difficult to couple to light sources. So single in the earlier pictures you have seen that the diameter of the core is very lesser. So if you want to couple it with the light source like LED and that laser diode, it is a bit difficult because its diameter is very less. These are the designing difficulties, and then what we can take is some key takeaways. So when we are going to use optical fiber, we must know what purpose we are doing, whether it is short distance communication, long distance communication, what type, whether it should have a high bandwidth or low bandwidth. Accordingly, it is in our hands how to choose the optical fiber. So mainly 4 parameters will decide the selection of the optical fiber. One is the distance over which transmission is going to be done, and what is the bandwidth, and what is the environmental conditions. If it is too high climate, then better to go for glass optical fibers. So environmental factors, too cold climates, what type of optical fiber to be chosen, all that, and the cost considerations also to be considered while choosing the optical fiber. Mode of propagation, which mode you want. Longer distance means you have to go for single mode optical fiber. So determines whether the fiber supports single or multiple light paths affecting bandwidth and distance. And then material composition also. Glass fibers offer giving superior performance for long distances and high bandwidth applications, but affected by radiation. So if you want to protect them from radiation also, you have to go for special designs, and fiber is made such a way that they could withstand the radiation effects. Plastic fibers are suitable for shorter, cost effective and less affected by radiations. Applications, already we have seen many. So optical fibers find applications in Wi-Fi router, landline phone and server connector. A single optical fiber can carry 3 lakhs full duplex voice calls or 90,000 TV channels signals at the same time. So it is used in broad bandwidth telecommunications. If it is very broad, it is better to go for single optical fiber. And in telecommunication, they find applications across the continents. If you want to communicate, our communication is that only. If we want to talk to anybody in America or any other continent, we use devices which use optical fibers. These optical fibers can be buried below the earth so that they will not be affected by the flood or the storms. So the transmission would be very, very effective. They are also used in medical devices and high precision instruments, and for decorative purposes also, in toys, in decorative lamps and all, we use these optical fibers. In military purpose, you can see optical fiber is used to make military equipment, and in weapons also for sending the signal and detonating and all through optical fiber only. It is it is used to make antenna to communicate to faraway areas. Okay. Optical fibers are also used in sensors. All of us know sensors are used to collect data from the physical environment, like change in temperature, change in pressure, force, acceleration, etc. can be sensed by sensors. In these sensors, optical fibers are used. Also, these fibers are also used to design detectors. Some simple pictures I show you here. So there are two types: extrinsic fiber optic sensor, intrinsic fiber optic sensor. From the light source, light can be passed to the light modulator and the output is given to the light detector. Okay. We know the physical parameters sensed by the sensors will be converted into electrical signals. Those electrical signals will be converted to binary digits, like in terms of 0 and 1, and these will be converted into light signals, and those light signals with the help of the light source will be passed through the light modulator and can be detected. At the receiving end, they will collect the light pulses. Whenever the parameter was not there, no light will come. When it is there, there will be light pulses. So that will be detected, and these light pulses will be converted back into decimal numbers and then electrical signals, so that we can easily understand what is the parameter measured. Advantages of fiber optic communication compared to metallic cable communication. So fiber optic cables provide wide bandwidth than copper cables. Also, the optic fibers will be immune to electrostatic and electromagnetic interference. So the noise will be very less. Also, the crosstalks could be avoided. So we can have communications which is free from noise and etc. Optical fibers are very lightweight and smaller in size compared to the copper cables, and the cost of preparation is also very low, and very low loss of signals take place in optical fibers, and the signals sent through the optical fibers will have higher security, because fiber cables are more secure than metallic cables due to its immunity to electromagnetic coupling and radiation. So optical fiber can be used in more secure environments. Also, these optical fibers will be more resistive to environmental extremes like extreme hot, extreme cold. All this, due to that, the fibers will not be affected at all. So they are very, very reliable and remarkable for communication of data from one end to the other end of the world. I hope you would have enjoyed today's talk on the types of fiber optical cables so that you understand the total working of optical fibers in various applications. With this, I conclude this talk. I thank you one and all. We will meet again in another topic of very interesting. Thank you one and all.